So when we talk about pressure, this is the definition of pressure. Pressure is defined as force per unit area. Remember I said for every 14.7 pound, this is force, per 1 square inch is equal to atmosphere. So can I say pressure is force, this is force, divided by unit area. Again, we already said 1 atmosphere, every atmosphere results to a column of mercury which has a height of 760 millimeter of mercury. We also said that 1 millimeter mercury is defined to be 1 torr in the honor of Torricelli. Same amount, different names, same amount of pressure, and therefore 1 atmosphere you can say it is 760 millimeter of mercury or 760 millimeter of torr. Torrs and millimeter of mercury are the same amount of pressure. All right, so these are the units of measuring pressure. Well, atmospheric pressure, 1 atmosphere. So we measure pressure of any gaseous system in atmosphere, or we can measure the height of the mercury column, which results from the atmospheric pressure. If you measure it in millimeter of mercury, 1 atmosphere is equal to 760 millimeter of mercury. Of course, this is the atmospheric pressure at Los Angeles at the sea level, not in Reading. In Reading, we are, I think, around 800 feet above the sea level. So our atmospheric pressure is lower than 760. Maybe 700, maybe 710, maybe 720. It changes every day. And another unit of measuring pressure is torr. And as we said, every 760 torr is also 1 atmosphere. Because we are measuring the height of the mercury column in barometer to show the atmospheric pressure, so can I measure heights in inches of mercury? In other words, you're measuring the height of mercury column in inches. And this is the abbreviation, inches of mercury. And as we said, if you convert 760 millimeters to inches, you get 29.9 inches. So every 29.9 inches of mercury is 1 atmosphere. And we already talked about PSI, pound per square inch. Every 1 pound per square inch is 14.7, approximately 14.7 pound per square inch. So that's amount that you have for 1 atmosphere. 1 atmosphere, 14.7 pound per square inch. And as I said, another small, tiny unit of pressure is Pascal. And every atmosphere is 100,001 and 325 Pascal. We show Pascal with PA. So these are all the units of pressure. As you are doing problem solving, as you're answering your homework, discussion, solving the problems in the book, or on our Zoom, we will use these units into our conversion factors, and also you have all this information on your exam table. Any questions so far, guys? Any questions? All right, I'll go to the next slide. Go ahead, use conversion factor to convert these units into each other. try to use the exam table because you get more familiarized with it and you can save time. During the exam time, you don't get nervous because you're already familiar with this table. Raise your hand when you are ready, please. Wow, 2 hands up already. Great job, guys. So the first part, guys, is conversion of 475 millimeter of mercury into atmosphere. So given millimeter of mercury, I want to cancel that to atmosphere. So I write what I'm canceling on the bottom, millimeter of mercury on the bottom. What I'm converting into, problem is asking atmosphere, write that on the top, and then relate top to bottom. Every 1 atmosphere is 760 millimeter of mercury. So what is conversion factor suggesting? Take 475 multiplied by 1, which is the same number, divide by 760, and this is the answer. The answer is in atmosphere because the unit of millimeter of mercury was canceled with millimeter of mercury on the top. So in part B, we are giving you a pressure of 2 atmosphere, and we want you to convert that into millimeter of mercury. So obviously, we want to cancel atmospheric pressure. We write that on the bottom. Problem is asking you to convert it in millimeter of mercury. We write that on the top. And then we relate top to the bottom. Every 1 atmosphere is 760 millimeter of mercury. ATM and ATM are canceling. What is left is millimeter of mercury. That is the unit that problem was asking. So now, what is conversion factor suggesting? Take 2, multiply by 760, get the answer, divide by 1, which is the same number, you get 15, 20 millimeter of mercury. Very significant figures here. So I must have 3 significant figures in the answer. Any question, guys? Any questions? Do you have any question? All right. So guys, we just said that we want to study gaseous system in this chapter. And we said any gaseous system has got 4 properties: pressure, volume, temperature, and number of moles. So in our studies, first I'm going to start finding out the relationship between pressure and volume. Are these 2 related together? If they are related together, how do they relate together? Obviously, if I'm going to study pressure and volume, I must keep these constant. So I'm going to keep 2 of the variable constant and ask, is there a relationship between pressure and volume? What is the relationship if I keep temperature and number of moles constant? So these are kept constant. So in this example, inside the cylinder, I have got 4 liters of a gas, let's say air. The pressure is equal to 1 atmosphere. I'm going to double the pressure into 2 atmosphere. And I want to see what happens to volume. Volume was 4 liters before I make the change. The volume at 1 atmosphere pressure was 4 liters. When I double the pressure, volume is going to change to half as much, to 2 liters. So pressure is doubled by a factor of 2. What is happening to volume? Can I say volume is reduced by a factor of 2? So apparently pressure and volume, if we keep temperature and number of moles constant, they work inversely. And that's reasonable, guys. If you are using your bicycle pump, as you're pumping, doesn't the pressure of the air goes higher? And what is happening to volume? As you're pumping, do you bring your pump halfway down the cylinder? So you're reducing the volume by increasing the pressure. So gas laws are actually result of experimental studies. So what is this experimental study showing? It's simply showing that pressure and volume are inversely related. When you double the pressure, volume is reduced by half. So one is double, the other one is half as much. They're inversely related. We increase the pressure, volume is decreased. Let's find out more accurate relationship between them. Let's continue doing 3 experiments. Experiment number 1, we have a container which has a volume of 2 liter, pressure of 8 atmosphere, and we multiply this, we get 16 atmosphere liter. That is the product of pressure times volume. Remember, in this experiment, we are keeping number of moles and temperature constant. Amount of the gas, which is number of moles, is not changing, and the temperature is not changing. We just want to study relationship between these two. So I go back to the same experiment, same gas, same amount of the gas at the same temperature. When I reduce the pressure to 4 atmosphere, volume is increased to 4 liter. If I multiply pressure times volume, I get 16 atmosphere. And then I get the same gas, same temperature, same amount of the gas. And this time, I start with a pressure of 2 atmosphere. The volume is going to be 8 atmosphere. When I multiply pressure and volume, the product is the same. So do you see, as I'm going from experiment 1 to experiment 2, as I'm going down, not here, well, let's say as I go down the experiment, do you see I am decreasing the pressure and volume is increasing? So can I say the relationship between pressure and volume are inverse, they are opposite to each other. One goes down, the other one goes up. This is only when we keep the temperature and amount of the gas constant. So Boyle used this experimental observation. He came up with this conclusion. At a constant temperature for a fixed amount of the gas, the product of pressure and volume remains constant. So we call this Boyle's law. We use this formula in solving and predicting the new volume if we change the pressure, or the new pressure if we change the volume. Again, under a condition where amount of the gas and temperature is not changed. So we call this Boyle's law. It says the product of PV remains constant as long as absolute temperature and amount of the gas and number of moles remains the same. Any questions, guys? Any questions?